Hello students. Now we continue this vector differentiation with the next concept. The next concept is divergence of a vector point function. So here, so this given function f is a vector function, so which is continuously differentiable. Then the divergence of this vector function f is written as div of f, that is we read as a divergence of f, or we write as a del dot f. This is the dot product we have, so where del is a differential vector differential operator and this f is a vector function. So this del dot f gives the divergence of a vector point function. Okay, suppose f is f1i plus f2j plus f3k, where f1 f2 are functions of xyz. Then we write divergence of f as, so this del is a differential operator dou by dou x into I plus dou by dou y into j plus dou by dou z into k dot the vector function f1i plus f2j plus f3k. We take the dot product of these two functions, so here we get dou of f1 into the dou of f1 divided by dou x plus dou f2 by dou y plus dou f3 by dou z. So this is a gradient, which is the gradient divergence of f. Okay, now this divergence of f is a scalar quantity. When we find the divergence of f, the result will be a scalar quantity. Okay, similarly, if f is a constant, the divergence of f becomes 0. If we have a c, keeping the constant c, we find the divergence of f. Okay, and remember that this dot product del dot f is not equal to f dot del. This point you remember. And so the one more definition, that is our solenoidal vector. A vector f is said to be solenoidal if divergence of f equal to 0. If the value of this divergence of f is 0, then the vector f is called solenoidal vector. Then we define the one more concept, that is called curl of a vector point function. If f is a continuous differentiable vector point function, then curl of f we write as curl f, or we take a del cross f. So this is the cross product we have. So taking the cross product of this differential operator and the function vector function f. Okay, so this gives the curl of a vector point function. Suppose f is defined as f1i plus f2j plus f3k, right, where f1 f2 f3 are the functions of xyz. Then curl of f we write this del then the vector function f, then this cross product is given by the determinant I j k, first row, second row dou by dou x plus dou by dou x, dou by dou y and dou by dou z as a second row, then third row f1 f2 f3. By solving this determinant we get a curl of a vector point function. Okay, and the outcome of this, when we find the curl of the vector function, the resulting will be a vector quantity. Okay, if the function f is constant, so definitely the curl of f equal to 0. Okay, similarly, and this f cross del is equal to del cross f. Okay, and the another definition is irrotational vector. So irrotational vector is what, when the curl of f equal to 0. If the curl of f value is 0, then the function f is called irrotational vector. So these conditions you please remember. Okay, so now we take some problems finding the divergence and curl of the given vector function. So here is one problem. So the vector is given as x z cube I minus 2x square y z j plus 2y z raised to 4 k. Now we have to find the del dot vector a. that is a divergence of A, and when we get the cross means it's a curl of A. Okay. And also we have to find the del cross A, okay, at 1 minus 1 1. First we take the differential operator del and this is the given vector A. We take the dot product of these two vectors. So here, as you know, dot product is dou by dou x of xz cube. Then we have a plus into minus minus dou by dou y of 2x square yz, then plus dou by dou z of 2yz raised to 4. We differentiate this with respect to x. X is 1 into constant z cube. Then differentiation with respect to y is 1 into constants 2x square z. Then with respect to z, so z raised to 4 is 2z cube. 2 into 4 into z cube. 4 into 2, 8 y z cube. So this divergence of vector A at the point 1 minus 1 1. So taking x equal to 1, y equal to minus 1 and z equal to plus 1, in this result we get minus 9. So this is the divergence of the vector A at the point 1 minus 1 1. Now we find the curl, that is del cross A. Yes. So del cross A we write as a determinant, first row I, j, k, second row dou by dou x, dou by dou y, dou by dou z, and the third row x z cube minus 2 x square y z and 2 y z raised to 4. And you know how to evaluate the determinant, this I into taking this cross product dou by dou I, dou by dou y of 2 y z raised to 4, that is 2 z raised to 4. Then taking this product dou by dou z of minus 2 x square yz. With respect to z you do, with respect to z means this becomes 1, we get minus 2 x square y, and this minus this into this, minus of this into this, so minus and this minus become plus, we get 2 x square y. Differentiation of z is 1. Then minus j into leaving this column and row, taking this product dou by dou x of 2yz raised to 4. Y and z are constants, 0. Okay. Then dou by dou z of xz cube minus differentiation of z cube is 3z square and x is constant, plus k into taken this cross product dou by dou x of minus 2 x square yz, okay, that is minus 4 x yz. Then this product dou by dou y into x z cube, with respect to y means x and z are constants, it become 0. So this on simplification we get this. Then we find the curl of A at 1 minus 1 1, taking x equal to 1, y equal to minus 1 and z equal to 1. So we get 3j plus 4k. Okay, so we have curl of A, that is 3j plus 4k. Now we take this del cross A and taking the dot product of del cross A. So this is our del cross A. So, okay, so here we have this one, taken this value, then taken the dot product of these two, that is dou by dou x of 2 x square y plus z raised to 4 plus dou by dou y of 3x z square plus dou by dou z of minus 4 x y z. So this on simplification the value is here 0. Similarly, the next two problems are very simple, so you do those practice those problems. Now we take some other type of problems. Yes, the other sort of problem, find divergence of vector f and curl of this vector f, and this vector f is given as this del of x cube plus y cube plus z cube minus 3 xyz. So del of this function means this is the gradient of the function. First we have to find the gradient of this, which gives the capital F. Then taking that F, we have to find out divergence and curl of F. Okay, so we take the function this x cube plus y cube plus z cube minus 3 xyz as a pi. Okay, then we find gradient of pi. So as already we discussed, gradient of pi dou pi by dou x I plus dou pi by dou ij plus dou pi by dou z k. Okay, taken this pi, we differentiate with respect to x partially, with respect to y partially, and with respect to z partially, taken that pi. So here is that capital F we got. Then we find the divergence of F, that is del dot F, taking del dot, so this is our F. Okay, now taking the dot product of these two vector functions, dou by dou x of 3x square minus 3yz, then plus dou by dou y of 3y square minus 3xz, plus dou by dou z of 3z square minus 3xy. Okay, now this we differentiate with respect to x. So this is 6x, 3yz becomes constant 0. Then with 3y square differentiation with respect to y, 6y, and 3x and z are constant 0. Then with respect to z, 3z square is 6z, x and y are constants 0. Therefore the result is 6 into x plus y plus z. So this is our divergence of that F. Then curl of F is del cross F, taking the determinant first row I j k, second row dou by dou x, dou by dou y, and dou by dou z, and third row from the F, from this F, this is first element, second element, and third element in the third row. Then this on simplification, evaluating the determinant. So as already you know, then the value of this determinant is 0. Okay, so this is the another kind of problem. Similarly you can try the other problems. Now the next type of problem is, so here the another type of problem, if A is a constant vector, find the first one is divergence of vector R cross vector A, and the second one is curl of vector R cross vector A. So this vector R, so as usually we define vector R as a xi plus yj plus zk, we define R. Then the constant vector A we define as a1i plus a2j plus a3k, where a1, a2, a3 are the constant. That's what these are. This we call as a constant vector. So this R is a vector point function. Okay, now to find the divergence and curl of this R cross A, first we need to find R cross A. So that is vector R we have, vector A we have, then the cross product of these two is given by the determinant ijk, then the second row from the R xyz, from the a1, a2, a3. Okay, so this we evaluate I into y into a3 minus a2 into z, then minus j into x a3 minus a1 z, then plus k into x a2 minus y a1. Okay, this is R cross A. Then it is very simple to find the divergence. Del cross R cross A, del dot R cross A, this gives the divergence of this R cross A. Taking del, then R cross A is here, taking the dot product of these two, that is dou by dou x of this term y a3 minus a2z, then we have minus here, so minus dou y of xa3 minus a1z, then dou by dou z of xa2 minus y a1. Now with respect to x, we do not have any variable because both y and z are constants. The differentiation becomes 0. Similarly here also we have constants x and z. With respect to y means x and z are constants, become 0. Then with respect to z, here also we do not have any variables, x and y are constants now, so that is also 0. The value of this is 0. Similarly, taken this r cross a, we find the curl. So this del cross r cross a is given by the determinant ijk from the del, second row dou by dou x, dou by dou y, dou by dou z from a. So this is from r cross a. From r cross a we have the elements. Now this on simplification, we simplify this determinant. Okay, so finally, so this you work out. So very simple, simply taking the cross product and simplification. So finally we get minus 2 into a1i plus a2j plus a3k. So a1i plus a2j plus a3k, which is a vector a. So this we write as a minus 2 into a. So this is the one problem. And similarly we take another one. This is also one different problem. Show that the curl of r is to n into vector r equal to 0. So here vector r is given, which is xi plus yj plus zk, and this r is magnitude of that vector r, means this r is to n. So here what we have to do, first taken this r, magnitude of r, that is square root of x square plus y square plus z square, that is denoted as a r, right? Then squaring on both sides, we get x square plus y square plus z square. This is the value of r square. From this function we find dou r by dou x, dou r by dou y, and dou r by dou z, because while doing this curl of r is to n into vector r, we need these values of the partial derivatives. Therefore, from this function r square equal to x square plus y square plus z square, we find a dou r by dou x, that is differentiating with respect to x. Differentiation of r square is 2r into dou r by dou x. The differentiation of x square is 2x. From this 2 cancel, we get the value of dou r by dou x as x by r. Okay, as this is the symmetric function, we can write it directly dou r by dou y as a y by r, dou r by dou z as a z by r. Now we take first r is to n into vector r is to n, then vector r. So this vector r, xi plus yj plus zk, to this we multiplied by r is to n. Okay, so this is the vector function we got. Then we take the curl of this r is to n into vector r. So for this we write as determinant of first row ijk, then second row this from the del dou by dou x, dou by dou y, dou by dou z. Then from r is to n into vector r, we have r is to n into x, r is to n into y, r is to n into z. This we simplify as I into dou by dou y of r is to n into z minus dou by dou z into r is to n into y. Similarly minus j into this product, okay, dou by dou x of r is to n into z minus dou by dou z of r is to n into x, plus k into dou by dou x of r is to n into y minus dou by dou y of r is to n into x. And one thing you remember, as in the note we define, so these three terms we write as a summation of this first term, we can write these three terms as a summation of the first term, so that we can reduce the number of terms. Yeah. So writing these three as a summation of this first term, so that it reduces the writing these two terms. Okay. Then this summation I, we differentiate partially with respect to y. So r is a function of y. So differentiation of r s to n is n into r s to n minus 1. Then again differentiation of r is dou r by dou y. Z is constant. Then minus n, again differentiation of r s to n into y with respect to z. R s to n is n into r s to n minus 1. Again differentiation of r is dou r by dou z. Then y is constant. And this we write as summation I n r s to n minus 1. So dou r by dou y value. So dou r by dou y value is y by r. That I substitute here, minus n into r s to n minus 1. Then dou r by dou z value is z by r into y. And this we write as summation I n r s to n minus 1 divided by r is r s to n minus 2, and this yz minus n into r s to, again this r s to n minus 1 divided by r is r s to n minus 2 into zy. So this plus term and this minus term cancel. Therefore the value of this curl of r s to n into vector r is 0. This is what the given result which we proved. Okay, the next problems we continue in the next video. Okay, thank you.